appreciate everyone coming out today. My name is Eric Mizell. I run the solution engineering team at a company called OverOps. But by way of background, I'm a software engineer. So I cut my teeth. I'm going to date myself here a little bit, but I cut my teeth on Power Builder. If any of you guys have heard that from Sybase back in the day, and switched to Java in 2004. Did a lot of work in .NET. Now do a little bit of Python and the like. But Java's kind of been my sweet spot. I moved into what's called field engineering, solution engineering, with a company called Terracotta. If you guys are familiar with EH Cache and distributed caching. Spent some time there, and then I worked at Hortonworks with Hadoop for several years. So I've been in a lot of different spaces of engineering, big data, distributed systems, and the like, and then recently joined OverOps. So what's interesting is watching the world shift, right? And so I'm going to kind of take you guys through a little journey and kind of the experiences that we're seeing with customers, and then personal experiences and the like of, you know, the differences in monitoring and observability of where we've moved from, because kind of like this move from operations to DevOps, right? What do those teams look like? This notion of continuous integration and delivery, and how do I get code into production faster, right? Like Amazon kind of set the precedence of, they're deploying like all the time. It's like constant deploy. And a lot of us come from the world, and we have a lot of different backgrounds here, but like come from this world of I'm deploying every 6 months or every year, and now I'm getting to how do I deploy every week or every month or every day or multiple times a day? How do I get there and know that the code I'm putting in production is reliable? And so that's where this notion of observability, or where we're going on how we understand what our applications are doing, meets the CI/CD process and be able to put guaranteed or better code into production, right? And then how do we accelerate that? So that's just kind of where we're going to go today. So just quick context. You guys probably know some of these things, so I don't want to go too deep into it. But you know, traditional monitoring is red, yellow, green, right? Monitoring my apps. Are they up? Health checks. You know, I might catch some telemetry data out of that and look at things over time. It's moved to this notion of observability, right? Where I want granular insights to what's going on. I need to build applications that are debuggable. Right? I need to be able to know failure modes, because there's so many different ways an app can fail. How do I know how to troubleshoot those? Look at logs, right? Like, how do I get better insights? And the world is moving to, I need to be able to solve problems faster, right? And so, like, if I compared the two, monitoring tells me, is my system working, right? Which is great, but observability tells me why. Like, I need to know why things are working or not working, right? So it's kind of this move of where the world's going in this observability pattern. So just the 2-second, like application monitoring, right? Red, yellow, green. We've got lots of tools to do this. You know, what are those tools? There's, you know, APM tools, log aggregators, network monitoring tools, and the like. I think the value that most people get from a lot of those is not only do I get to tell if things are working, I see trends and the like, but it's how do I tell for capacity, right? Financial planning, like look at the loads and trends over time. That's what I get from a monitoring type tool, right? Performance engineering, reporting, like I have to report up to others. That's what I get. But what do I want? This is where this observability comes from, right? I want to be able to measure how well the internal state of a system is by looking at what it infers from the external outputs, right? What can I tell from my application that helps me understand what's going on, right? What are the goals that I want from this stuff? I want deeper insights. So I'm sure a lot of you guys are getting into the microservices and distributed transaction workload, right? How do I know? How do I do event tracking and tracing across all of those and correlate that back, right? These complexities are coming up more and more. I spent a lot of time today talking with some of you guys and a bunch of others about, you know, distributed workloads and tracing, especially if an asynchronous world. How do I know it completed? How do I know what's going on end to end, right? And so there's a host of tools out there. We've got all these different tools we're looking at, right? Like different APM tools that are spinning up. There's new frameworks that are coming up. Third-party libraries to emit data, you know, from a tracing perspective. There's a bunch of different ways to look at this. And then when I look at the challenges, it's like I said, how do I know? How do I get context of what's going on, right? That's the biggest challenge for all of us, and especially when it's not in an environment I have control over, right? So Sarbanes-Oxley kind of pushed us into this world. I live this day where I used to be able to see production data. Now I can't, right? And if it has to be redacted if I see parts of it. So how do I recreate issues if I don't have the environment or the data, right? Those complexities are killing us. So part of what's coming out of it is like new teams. So DevOps, you guys are very familiar with. Now site reliability, so teams are spinning up, right? And site reliability teams are forming. They're more engineering based. They're looking at metrics, data, what's going on inside my apps, those types of things to help figure out why things are being breaking. I'm starting to see teams form where like developers are focused on core components and building tech, and they're not necessarily responsible for fixing it. So site reliability teams are now fixing some of this code, and they need to have better context. So I'm watching these paradigm shifts of how things are happening, right? So when I start thinking of, I need monitoring, super important. I need this observability, right? I want to know why my apps are breaking so that I can help up-level my teams and get more insights to what's going on. And so that kind of leads me to where the world's headed with the CI/CD, right? So I'm building on all these components of, I've got observability, more insights into my apps, and it feeds into these trends of CI/CD, right? How do I get code into production faster? That's the world we live in, right? There's the notion of 6-month delivery cycles are over, right? And a lot of people have monoliths. I'm trying to move to microservices. I need to make things repeatable. I need to get into production faster. It's a cultural shift, right? So a lot of companies like startups are doing this out of the gate, right? Like it's not a big deal. But for a lot of existing companies, how do I make the switch culturally? How do I get deeper understanding into where my failures are, and how do I get a feedback loop? I think that's another challenge, right, is as I promote code, how do I get the feedback back to the right people to get it fixed? And I tell you, I get a lot of different stories of this, and I'll share those with you. The risks that go with continuous deployment is code coverage, right? So how do I have the right test code coverage? I get that a lot, right? Like we assert values and we do testing when our code is promoted, and we think we've got code coverage and things are still breaking, right? Constant breakage. How do I get better code coverage? And so what comes from that is new types of techniques, right? So when I promote code now, you start to see like canary testing. I'm sure some of you guys do canary testing, A/B testing. I'll take my customers and I'll route 10% through the new build. And if that stays stable, then we'll put 20% and 30 and so on until we say, okay, this is solid state. Because we don't know. Like I don't know where my errors are, so I have to take calculated risks by doing these types of things, right? And at the end of the day, it has to be automated, right? So here's the challenge for all of us is how much automation do we have and what do we need, right? And how do I know from the time I check in code to the time it's built to the time it's promoted? How do I have metrics on that? How do I capture that information and get the proper feedback and alerting? And so when I look at observability, that's going to give me those insights to help my CI/CD process, right? Those things come together nicely. So I'm going to take you through a couple of workflows, and like in a perfect world, wouldn't this be great? Code is checked in, automatically built, goes through its iterative cycle, gets promoted, all my testing works, all my automation's in place. Something fails, I get an alert. I got code monitoring code for me. Nobody touches it, and we know it's in good shape, right? Now, obviously, there's nothing perfect, but that'd be great. Like, it's all automated, it's all working perfectly. That's what we all want to get, right? That's that whole Jedi Java powers, or even if I was .NET, like everything's working perfectly. But let's get into the reality. So here's the first reality check. How do I detect the errors? That's one of the biggest problems I run into myself and even with customers, right? Like, how do we know? And so most of the time what I get from a lot of my customers is we do volumetric alerts, right? So I set some sort of a volumetric alert in my APM or my logging tool. Hey, if I have so many of these errors, give me an alert, right? Or how many of us grep the logs? Grep the logs and see how many errors I have from this latest release, right? Or the worst of all, customer calls and complains, right? Or someone says, hey, this didn't work, and you're looking through the logs, or someone tweets about it. Hey, this failed. Hey, I was working on this website and it failed. That becomes the worst, right? So now I've started to have all these different issues. How do I detect those errors, right? Worst of all, what if it's not logged? So how many of you guys run into swallowed exceptions, right? So I could give you just, you're gonna love this. So when I ran my engineering team, we had a code partner, and they were responsible for building certain aspects of our software. And what was happening is that code would come back and it was full of bugs. And so we had this mantra of, you know what? Let's backcharge them. We're going to backcharge them for all those errors. So we told them this. And the next release came in, no errors. Magic how that works, right? QA team was like, whoa, everything works. Went into production. The first phone call I got about an hour into the day of release was nothing saving to the database. Like, what do you mean? Well, we entered all this data and nothing's there. So, of course, I'm on a conference call, we're on a WebEx, we're going through this. I had to fly on site. Like, I don't understand what's going on. At the end of the day, this is exactly what happened. So our code partner actually started swallowing the exceptions. They couldn't get the code to work, so they just ate it, right? Welcome to the world of running a big engineering team, right? How do you know? There's no way. That's never in a log. So that's a challenge, right? That's a huge challenge. I need something that can tell me my unknowns. What if I handled an exception? So you guys write code. I've got error handling at a high level, right? So that's my generic catching of everything. But a lot of times what happens, I see with a lot of customers, they don't have generic overall error handling. And so what happens is they'll have try-catch that's catching a SQL exception or something to that effect, but along the way there's a null pointer that happens and it's not caught. You know what happens? The thread dies. No logging happens, right, at all. How do I know how to catch that error? If I have a higher level error handling, which is great, I'm going to catch the exception, but what about all the other things? Maybe files didn't get closed or something else along the way was happening. There's no way to know, right? So those things pile up. I need to know. I need to know these things, right? Next problem that happens. Once I detect it, how do I alert it? How do I get alerted? How do I route it? So super interesting story. So I'm working with a lot of retail customers. And one of the biggest things is how do you know? So my wife actually was buying on their website of this company on Cyber Monday. Favorite day to shop, right? And the shopping cart kept failing. She hit submit, it failed. She hit submit, it failed. Two types of people in this world, right? My generation, my wife, called in, right? She said, hey, and they took care of her, right? New generation, millennials, what are they going to do? I'm done with those guys. Never coming back, right? They walk away. Both of those cost you, right? Both of those situations cost you. I need someone in a support center to take a call because my website doesn't function properly, or I'm losing customers. It's a brand problem, right? How do I know? Ironically, that same customer that we just brought on board 4 months later, their VP of marketing came into the engineering team and told them that their wife's shopping cart failed. This is 4 months later, still going on, no one knows, right? Like, it's crazy, right? So how do we know? Volumetric alerting is one of the things I get a lot of, right? Setting it to meet if it happens so many times within the time frame. What if I don't reach that time frame, right? That's a problem. Grepping through the logs, tailing the logs, aggregating the logs. I get a call from a customer, all those things, right? Those are all of our challenges, right? So this is a quote, right, from one of my customers. Once I detect the error and I alert it, they're getting, how do I get it assigned to the right person? So these folks are getting hundreds of improperly assigned errors. So they sit in someone's queue, it's assigned to me, but it's not my problem, it's your problem. It's your problem. So they get finger pointing, so nothing's getting solved, right? So how do I, once I detect it, I want to get it routed to the right person, right? Or the right dev team. It's another important factor of getting better code quality into production, right? Last component. How do I know when to promote code? Anyone's guess, right? Bob in QA says we can promote. My favorite of all time, customer told me flat out, we query Splunk, and if it's less than the last time, we promote. What's less than last time, right? It's crazy. These are the things that everyone's doing. I grep the logs. That's one of the things I hear the most. I go look at my logging framework. How many errors do I have? How do I know? And then the thing is how do I classify those errors, right? So what if, look, we all have errors in our apps. It's part of the world we live in. Sometimes we have retry logic. Sometimes we have, it's acceptable to fail. That's just the noise that we can live with. But what if we could classify those errors? These are new errors. These are resurfaced errors. Or if I could classify it by a specific part of my code, revenue generating or critical component of my code, and if there's an error there, I could be alerted on it. and know. So when I get to a code promotion state or a CI/CD gate, I can make a call to something and says, hey, give me the notion of should I promote this code and have better insights into what's going on, right? It's super critical. So if I have these types of errors, I have these types of situations because I don't have enough code coverage. I'm not detecting all the errors. So there's the unknowns we talked about, the swallowed exceptions, and how do I know, right? A lot of times it's too late. I found out it's too late. I have to promote the code because pressure from my boss says I have to promote. There's no good way to know. And what does all this lead to? Right? Tons and tons of errors, right? And it's crazy the amount of errors that are going on. And so you guys, we all use apps. I have a lot of my favorite apps, and believe it or not, every time I use it, it crashes in the same spot. Nobody knows. It's crazy to me. Applications that are failing, and this is brand tarnishment. This is, there's so many companies are falling out of business because they can't keep up, right? So the good news, why we're here, right, is because there is a better way. There's a better way. And so I'm just going to walk you through quickly about OverOps. I want this to turn into the whole OverOps spiel, but the company I work for, it's interesting. The reason I joined this company is back in the day when I was writing software for a living, when we deployed to companies, we had no idea when things failed how to recreate it, right? And so we'd be on, like I told you, on WebExes. You had to go on site. We had war rooms that it would be all hands on deck for hours, days, sometimes weeks. And I was sitting at lunch with one of my engineers, and I'm like, wouldn't it be great if when an error happened, we could actually get the variables, like the data that caused the error, and get it an alert, like an email, so I'd know, and I could be ahead of it and say, hey, yeah, I know you had this problem, here's the workaround, or we're working on it. And I stumbled into OverOps, and actually that's what it does. So it is a native agent that runs next to your application, and it detects those errors. So its job is to capture the errors and capture the variables that created that error, and capture the entire JVM or .NET CLR state at point in time with no code changes at all, right? So I don't have to change an ounce of code. I just turn this agent on. It captures the data, whether it's swallowed exceptions, so I showed you those massive swallowed exceptions, unhandled exceptions, knowing the unknowns. And what's interesting as it works is once we capture the data, we actually do a lot of aggregation as well. So when I think of the amount of errors that we can have, to be able to have a screen that shows me all of the errors, how many times it fails, and I'll show you some of this stuff here in a minute, percentage of those errors and the like, it becomes enlightening to what's going on inside your application. So when I talk about observability, what's actually happening inside my code. The other pieces that you get from this is being able to enable different teams. So if I look at where we're going from, I want my developers developing and innovating, right, new code. And as I move up the stack to DevOps, site reliability, QA support, these teams are now chartered to actually fix a lot of those issues. How do they do it? They don't know the code, but if I can show you your code and your variables and the like, I can fix code, right? I have more power to make change because I can actually see it. So it becomes super interesting. How does this fit in, right, to your pipeline? So what's interesting is, we talked about one of the biggest challenges is the feedback loop and the gates. So as I'm moving from dev, test, staging to production, I want to know what's going on, right? And what's been interesting for me in this new world that we're in, when we turn OverOps on for customers, the amount of errors they see out of the gate is really eye-opening. And being able to know, so I'm getting it, and I'm getting a feedback loop. So proper alerting and error detection and reduction of noise, right? So if an error occurs, I can put it in the right person's hands. I classify code by application, by component of code, and send the alerts right to the right people at the right time. So I'm not spattering the whole world, right? And as I move up the stack, the further up those errors get in your code promotion process, the more expensive they are, right? Because it's brand tarnishment when I get to the far right, but now I have to fix it back and start it back through that whole release cycle. So the sooner I find things, the sooner I can get to resolution, the less expensive it is. So let's go back to our fun workflow here. So when I think about the observability, knowing what's going on inside my application, and I think of this iterative cycle of code promotion, getting code to production faster, I want to get to automation, like we're talking about, with code monitoring code. So I'm detecting all your errors, right? Everything, whether or not it's logged, because when I'm not monitoring logs, I don't care about your logs. I care about your application, right? So I'm monitoring everything. When it's detected, I detect it instantly, right? And I can alert you instantly. You set the rules on how often you want to be alerted, what you want to know. I'll give you all that information, and I'll send it to the right team, because you set the rules. Like, it's not just blasting everybody, right? And then when it comes to promoting, this is one of the biggest things I run into, code promotion. So we have an API that says, go give me for this latest release. So if you think about when you're releasing code now, it's not one application anymore. It's dozens sometimes, especially in a microservice world, right? I can make an API call to OverOps and say, for this deployment version, how many errors did I have? How many were new? How many were from the classified errors that I classified? Like, so maybe if it's a database error, I want to know about those. Or if it's something that's mission critical or revenue generating. Like if that, like, it's funny, I'm going to digress for a second. When I worked at Hortonworks, we did a lot of market basket analysis. Anybody do that before? You guys know what I'm talking about? The whole market basket analysis is, why do people not buy from their shopping cart, right? So I'm putting a bunch of stuff in and I abandon it. I don't think anybody really looks at how many times that crashed, right? And so if I hit save and the shopping cart crashes, then it doesn't look like I abandoned it. It never worked, right? And so I want to know when those types of things happen, right? And so we're going to give you that kind of information. When things fail, you're going to get it, right? So how do I know when to promote, right? And I'm going to give you that information. So that would be a mission critical component. If something fails in this region, I want to know. So I don't promote code. And again, from an automation perspective, you make a call, you get back a JSON, and you can parse that JSON and say, okay, should I promote, should I not promote, right? So it changes the game. So when I look at this, finally, right, code monitoring code, that automation part. So I don't have to call Bob and QA, can we promote, right? Are we done? That meets that observability pattern we were talking about in the beginning, right? The measure of how well the internal states of a system can be inferred by the knowledge of its external outputs, right? OverOps is monitoring for you, giving you that information dynamically. You don't have to go and write anything. You don't have to go write a regex query or grep a log to go figure out what's going on. We're telling you as it's happening, live. So I'll just quickly show you a couple screenshots so that you get a flavor for it, and then I'll take some questions. So I love calling this the OverOps report. So this is our dashboard. You come down to our booth, we'll show it to you. But if you guys can see that reasonably well, it's sorted by deployment. And so it kind of goes back to what I was talking about in the beginning, is by deployment, and you can see the very top one is version 04, is it 421? 0421? It tells me how many errors, how many error locations in my code, and how many are new, right? So when you have that kind of granularity just out of the box, is huge, right? Being able to see what's going on. Shows me when the error was first detected, what version of the code it was detected in, when was the last time that error occurred. And when I actually drill into any one of the errors, I'll actually give you metrics on how many times it occurred, out of how many times the code was called. So once we get an error, it's pretty interesting. The code might be called 1 billion times a day, but it might only error 1,000 times. And we'll give you that. We'll give you those kinds of metrics so you know, so you can prioritize what needs to be fixed and what not needs to be fixed. What's interesting is if you compared it to like a logging framework, if I had 1 billion errors a day from a piece of code, how many entries am I going to have in my log? 1 billion, right? 1 billion. For our perspective, we'll have a snapshot, which I'm going to show you in a second, which is that data and your code. But I'm going to have aggregations. I'm going to tell you it happened 1 billion times. And I'm not going to trouble you with the overhead. You don't need to look through 1 billion log entries to figure out what's going on. I'm going to give you one granular view, right? The other piece is it's super important, is metrics, right? I want to know code quality, release over release over release. I can show you that, right? I got it right here. Version 422 versus 421, I can show you code quality. We actually export all of our data by statsd. So a lot of people using InfluxDB, using OpenTSDB, whatever time series database, and your favorite visualization tool on top. I can show you code quality by application, by deployment version, and the like, so you can actually see the trends. And that's super important for site reliability teams, DevOps teams. They want to know what's going on, right? So it's that whole know your own knowns. So this root cause, and please stop by later if you're interested. We'll show you a little deeper. But this is like the money shot. This is that component that every developer dreams of, right? Is how do I know when it failed? And what did it look like at that point in time? So our ARC screen, which is root cause analysis, shows you, as you can see on there, I'm highlighting a piece, will actually show you your source code, and you hover over your variables, and it'll show you the variable value. So knowing the value of every variable as it goes through the entire call stack. So if I had a call stack that was 50 methods deep, it's going to show you stack by stack by stack how I got there. I love how many of you guys, being an engineer, I've lived this day where someone submits an error and you get the bug and you're trying to recreate it and you can't recreate. So we either close the bug with one of two things. One, cannot recreate, or my favorite is, works for me, right? Exactly, right? So we have no other way to know, like we don't have any way. So, but if I have the data, then I can recreate it. One of the things that's nice is we can actually export that data for the entire stack of frames so that you can create a test case. It's one of the things that everyone likes to do is create more code coverage, right? So I have a failure point, I fix it, I create a test case so I make sure it doesn't happen again, right? The other thing we don't show in this snapshot, one of the things that is super useful is, I don't know how many of you guys have done this, where when you're trying to figure out why something's failing, you put in log entries, log.info, log.debug, log.trace. Those don't show up in your typical logs because in production you're in log.error, right? So you're only getting errors. We'll actually capture the last 250 log entries that won't show up in your logs. So if you had a log.info or debug or trace kind of showing you how you got there, we're going to give you those as well. And we'll give you your environmental variables, your memory state, and your thread state as well. So all the components that you would need to solve your problem, right? So having used this tool and having lived in this world, taking an issue that happened with a customer that took me a week down to hours is pretty transformative for me. So it kind of gives you guys a flavor. I don't want to go too much into like the whole OverOps world and the like, but it kind of gives you a flavor of where OverOps plays into the observability, like knowing what's going on inside your application, knowing when errors happen, detecting them, routing and alerting them to the right people. So whether you guys are Slack or PagerDuty or HipChat or Stride or whatever you're using, we would orchestrate those. We also can fire a Jira if you want as well. So a lot of people use every new issue creates a Jira. So the whole point of it is to try to work the way you work, right? I don't want to have to go to the dashboard to see what's going on. When the errors are detected, I want it to fit into my workflow, into my world, and we certainly integrate with all of those components and make it seamless. So if you're a developer, site reliability, DevOps, doesn't matter, you'll get the alerts you want, and you'll be able to get the insights you want to get to the ARC screen if you need, or if you're a metrics guy, we export to your tool automatically, so it becomes very transparent under the covers, so you're not having to spend enormous amounts of time trying to go figure out and read a dashboard. I hope this was useful. Appreciate you guys. Please stop by the booth if you're interested. We'll take you through a little deeper.
Thanks so much, Eric.
Thank you.